Hello, I'm going to walk you through now the week 2 task. I think you'll quite enjoy some of this task. It does involve doing an actual activity and building things, and that'll hopefully help you understand what we're doing. If we just go down to sort of the first question, what we're aiming to do here is to have a go at actually building the model. So for instance, to build H2O, you'll need to find two hydrogen atoms. Remember, they're the little white balls, and one oxygen atom, which is the slightly bigger red ball, and then join them together. And when you've built it, you'll be able to actually draw what you've built. So you might have built something like with the two hydrogens will be there, and you'll find that when you attach it to the red oxygen, with the way the holes are in the red oxygen's over here, your bonds are going to actually be at an angle. So water is a bent molecule, and you'll actually go and have a go at building this particular molecule. So basically that's what, so I'm just trying to fill it all in here. So you'll draw what you've built. If you don't want to draw what you've built, your other option, which would be a good option, is to actually go and take a little picture and make a sort of put it in Word or something like that. So it's a small size picture, and print it out and pop it in there. But you can actually draw what you've built. So here we've got one oxygen atom and two hydrogen atoms. So we can see that with the way the holes go, you can't really build it any other way, and that's why water is H2O. So the little 2 refers to the amount of hydrogen. So it refers to the symbol that you see just before, which in this case is the H for hydrogen. Okay. In a similar way, we could go and build carbon. So I'll go and do that now. So that'll be the carbon atom in the middle, and you'll notice that the carbon atom's got 4 bonds to it. So there's sort of 3. There's one that's coming out of the board, 2 that are still going like that, and then there's a final one, which I'll draw with a dotted line, that goes kind of into the page. And this is more obvious when you actually try and build it, because you'll see it's very much a 3-dimensional shape that goes into the page. And then attached to the end of these, just like before, we have our hydrogen atoms. So there's a hydrogen atom there, one into the page, and one there. And you can see here we've built that, and you basically do the others in a similar way. Then we get on to the next question. Question 2, and the biggest and the only real difference between question 1 and question 2 is when you get to question 2, you're actually having a go at building them. So if we look at the first one, let me just go and find the appropriate colour for the first one. If we were building this particular atom, we'd first of all put our sulfur atom here, which is the yellow atom. Hopefully you can see the yellow on your page where I'm drawing it here. And attached to the yellow, you'll find that the only way you can put the hydrogens is sulfur's only got a couple of holes, so one there, and it's also, these holes are on an angle, just like they were with water, and so when you draw it, you'll get something looking like that. And therefore your formula is you've got 2 hydrogens, because remember those little white balls are hydrogen, so your formula would be H, and there's 2 of them, and there's 1 sulfur, so H2S. And then in a similar way, if you did the next one and tried to build fluorine, you'll need to pick one of the green ones, because they represent the halogens, so they represent either fluorine, chlorine, bromine and iodine. So you'll have a green one for the fluorine and you'll have one for the hydrogen, and this time round when you connect them up, you'll notice that they actually form you only really need 1 connector, so that means that there's 1 of each, and so the formula is just H, 1H and 1F, so just HF. You don't need to write any little numbers below, because there's just 1 of each. Okay, that's that question. Let's press on to the next question. When we get to this question, what we're looking for is the idea that when atoms choose to bond to each other, they will bond to each other so they end up looking on the outside like a noble gas. So that means that sodium, which has got one electron on the outside, will just lose its electron, so it's looking like neon, which is the previous element that's got a full K shell and a full L shell, so that the extra electron in sodium's M shell just disappears. Or it doesn't disappear, it gets transferred onto another atom. So if I'm sodium and I'm sketching sodium how it is normally, I'm going to be drawing in the middle. I'm not going to draw the individual dots this time, so I'll be drawing sodium's got 11 protons. I'll just write P for protons, 12 neutrons, and then on the outside we've got our 11 electrons. So in the K shell we've got 2 of them, 1, 2. L shell we've got 8. Look at the L shell drawn here. Four, 5, 6, 7, 8, and then in the next shell, which is the M shell, there's just 1 electron. And the only difference is that now, when we draw the atom this time round, we lose that M shell electron. Still got 11p, that doesn't change. We've still got our 12 neutrons, that doesn't change. But now around the outside we've got 2, just like before, and 8. But we've lost our 1 around the outside. So that means 3, 4, 5, 6, 7, 8. Let me just check I've counted up properly. 1, 2, 3, 4, 5, 6, 7, 8, and 2 is 10. So we've lost 1 because the M shell electron's gone. So therefore that means there are more protons than electrons, and therefore its charge is now 1 plus. It's got 1 extra proton. Okay, let's go down and do the next one, and once you've got the idea of the next one, I think you'll get the idea of being able to do them all. In this particular case, fluorine has got 9 protons and 10 neutrons. It's meant to be a 9 protons, 10 neutrons. And then on the outside, this time, there are 2 in the first shell, the K shell, and then its L shell has only got 7 more because all up it's got 9, so 2 and 7 make 9. 1, 2, 3, 4, 5, 6, 7. So it can actually take 1 more, and it wants to again get to neon because neon's got 10, and neon is its closest noble gas. So this time when we redraw it with our 9p, now 10 neutrons, we're going to be drawing first of all our 2, 1, 2, and then this time it's going to want to get, sorry, it doesn't look like a circle, this time it's going to want to get an extra one. And so that now it's got its extra one, then it's now going to have a charge of 1 minus because there are now more electrons and protons. So in summary, what we're aiming to always get is a noble gas configuration. Sodium's 11, the noble gas neon, which is the closest one, is 10, so it's going to lose 1, and has now got its 10. Fluorine's got 9, its closest noble gas is neon again, which is 10, so it's going to gain 1. So it's going to end up with an extra electron, and so when fluorine forms compounds, it always grabs an electron. And you'll notice a pattern that if it's a metal elements are the losers. They will donate their electrons, so sodium will get rid of 1. If I'm, say, magnesium, I've got a couple on the outside, I'll try and get rid of my couple. Whereas if I'm a non-metal like fluorine or oxygen or chlorine, I'm going to try and grab some electrons. Fluorine will grab 1, oxygen will grab 2, chlorine will grab 1. So non-metals tend to be the grabbers, and metals tend to be the donators or the givers. Hopefully that will clarify that, and you should be able to finish that. Let's move on to the next question. Let's just see if they've got more stuff down the bottom, and then we'll go to the next page. Okay, when we start writing these things, we can show that atoms like sodium expect to lose electrons by that little plus sign. So the little plus sign says that sodium loses 1, which means there'll be now more protons than electrons. Potassium loses 1. Magnesium has got a 2 plus, so it loses 2. And then the same with the other atoms, the non-metals. Fluorine just gains 1, so it's got a minus sign because it'll have an extra electron. Remember, electrons are negative. Chlorine gains 1. Oxygen gains 2. Sulfur gains 2. In fact, you'll notice that all the elements in the halogens column all gain 1. All the elements in the oxygen group column of the periodic table all gain 2, just as all of the alkali metals all lose 1, and all the earth alkali metals, the ones next door, lose 2. So there's certain patterns in the table depending on how far away they are from the noble gases. We call atoms that lose electrons and therefore end up becoming positive, we call those atoms cations. So this word cation, so these would all be cations over here. In fact, if we go down further, we'll see we've got a fourth cation, that's aluminium, that's 3 plus. All of the ones along here, oops, clicked on the wrong thing. All of the ones along here are anions. They are the gainers, so they become negative. And just like we had a look earlier, if I've got sodium, which is a loser, and fluorine, which is a gainer, sodium loses 1, fluorine gains 1. When they form a compound, they just stick 1 to 1 together. If I say go to potassium and oxygen, potassium loses 1, but oxygen wants 2. So that the only way I can form a compound where everybody's happy is to have more than 1 potassium atom. So if I've got 2 potassium atoms, each potassium atom can give 1 of its electrons to oxygen. So 1 potassium atom will lose 1, the other potassium atom will also lose 1, and oxygen can then gain its 2. So you can start to see here how the formulas change. So in this particular case, potassium oxide, which is the name of this compound, will have 2 potassiums and 1 oxygen. Okay, let's move on. And now we do a similar thing. The only difference is that it's possible to have some anions which are a group of atoms. So rather than being a single atom, they can be a group of atoms. So here we have the nitrate anion. If you're curious about why it's called nitrate, have a look at the right-hand side of your periodic table where the names are all listed. So look at the very right-hand side and you'll see all the anions listed, and this is called nitrate. Generally speaking, an anion that's got quite a few oxygen atoms in it has an 8 ending. So it becomes nit for nitrogen and 8 for nitrate. Ones that don't have any oxygen, like the ones that we had above here that didn't have any oxygen, these end up with an ide ending. So this becomes fluoride, chloride, sulfide, and the one with just oxygen and nothing else becomes oxide. Alright, let's go back to where we were, down here. Let's go and have a look. So, the way it works is with this group of atoms, this sort of extra electron just floats around between all the atoms, and they act like a little gang. But from the point of view of working out the formulas, it's very, very similar. The only thing you need to remember is if you've got a whole gang and it needs to be repeated because it either needs to donate more or to get more, then you've got to repeat the whole gang. So let's just do one. Magnesium is 2 plus. So that means it's giving 2 away. But this one over here, OH, which because it's got the name of hydroxide, this only gaining 1. So that one of magnesium's electrons will be gained by one of the hydroxides, and we'll need a second hydroxide to get the other electron off the magnesium. So all up, if we do the formula, we'll have 1 magnesium, but we need 2 of these things repeated, so that we can do that by writing the OH, which is the formula for it. We'll put it in brackets to show the whole thing gets repeated twice. So that would be our formula in that case. I'll leave you to fill the others out. Please go and ask questions if you need some help. Okay. We've now moved on to the next page. This I think you'll actually find easier than what we've been doing so far. If we're going and working out the names of compounds, we can just look at what's written on our periodic table. Down the right hand side are the names for all the anions. So go and have a look down the right hand side, because that's the last bit. Remember, the last bit of the anions. So you always start off with the metal atom. The metal atoms just have the name of the element on the periodic table. The anions go for the name that's written. You'll notice the ones without oxygen as part of the anion have an "ide" ending. So this first one over here would be sodium, which is the name of the metal. And then for the name of the non-metal, which is bromine, we wouldn't write sodium bromine. We'd change it to sodium bromide. For the next one down, again, the same idea. The K is potassium, so we just write down the name of the metal. There's nothing special about this part of the name. For the other part of the name, we then look at the NO3. And NO3 together is a gang, and the gang has a name. And the name of it isn't nitrogen oxygen, it's actually called nitrate. And that's the name we'd write down. Generally speaking, an H ending, like nitrate, refers to an atom that's got a good amount of oxygen in it, so potassium nitrate. Now, some of you may be wondering, say in the case of potassium sulfate up here, why we don't, when we write down the formula, say that there's 2 potassiums. If there's no ambiguity, that is, potassium sulfate is always K2SO4, it can't be anything else, then we would write it down as potassium sulfate. We wouldn't need to write it as dipotassium sulfate to emphasize that there's 2 potassiums. So with a formula, you only need to use prefixes like di for 2, tri for 3, tetra for 4, pent for 5, hex for 6. You only need to use those sorts of prefixes if there's more than one possibility. If there's just one possibility, which is the case with potassium sulfate, people don't bother to put the prefixes. But say if I was looking, I'll just write it down over here, if I was looking at, say, CO, and CO2, which are both 2 different chemicals, then I'd call the CO one would be called carbon monoxide, because there's 1 oxygen, and then this one will be called carbon dioxide because there's 2 oxygens. So prefixes like mono, di and tri, etc. will only be used if there's more than one possibility. Otherwise, people don't bother to write prefixes in. Okay, let's go down the page to our final thing that I'm going to work with you through. The rest I'm going to leave up to you. Ionic versus covalent bonding. The explanation is fairly self-explanatory here. The simplest kind of compounds, and they're the ones we're going to spend most of our time looking at this year, are what we call ionic bonded compounds, and they have metal and non-metal atoms. And what happens is the metal atom donates its electrons to the non-metal atom. And we call the metal atom the cation and the non-metal atom the anion, because the cations lost electrons and the anions gained electrons. It's also possible to have bonds between atoms where rather than the electrons being donated, they're shared between the atoms. So they exist between the 2 atoms, so they kind of belong to both. And we call those covalent compounds. And the covalent bond, it sounds like it's weaker because there's no donating and there's no grabbing, but it's actually just as strong because the electrons are still between the atoms. So covalent bonds generally occur between non-metal atoms. So it's a fairly easy job. If you look at something like carbon dioxide, it's obvious from your periodic table that both carbon and oxygen are non-metals. Therefore, it's got to be basically a covalent bond. Whereas if I go to something like lithium chloride, it's fairly obvious that lithium's a metal, chlorine's a non-metal, so lithium chloride's got to be an ionic one. So just by looking at whether it's made up of entirely non-metals or a metal and a non-metal anion. So in other words, if there's a metal in it, it's going to be ionic. If there's no metals in it, it's going to be covalent. It's really, once you get the hang of it, that easy. In terms of the extra questions to do with hydrogen bonding and isomerism, I'm going to let you go and look at the other videos to find out that information, or feel free, once you've had a look yourself, to ask a teacher. So that's the explanation for this week. Thank you.